Hello and welcome back again to our channel, Tutoring Made Easy. I hope each and every one of you is doing well. I hope you're doing well. I'm excited that you're doing great. I'm excited that you're doing great. If you're not doing great, I pray you get back to your element. Everything will be working out perfectly for you. But today in this video, we are going to be looking at binomial theorem, and in this topic, it's an all-in-one lecture, like your go-get-to video where everything that you need on this binomial theorem topic is addressed, or the tools that you need in solving any binomial theorem problem is addressed for you. So we are going to start, but before we do that, I would like to take you through uh, the content of the video. So the video is going to be pretty much in three parts. So we have binomial theorem as usual. So the topic is binomial theorem. And I'm saying that the content of this video is in three parts. So we're pretty much going to be looking at three things here. So this topic, we have it in three parts. So we have part A, let's say part A, and then we have part B. Let me quickly, we have part B, and then we have part C. So in part B, and then we also have part C. We have part C over here. Now for part A, we'll be looking at just the definition. We're looking at the definition. We're looking at the definition of a binomial, the meaning of a binomial. And then the part B is going to be in so many segments. I think six. It's going to also be broken down into six categories. I'll be broken down into six categories. So let's take a look at that. This part B, we're saying that it's going to be broken into six categories. Going to be broken down in six categories. Yes. So the first category is where we're going to be looking at the Pascal triangle, solving a binomial theorem problem using the Pascal triangle. So we solving binomial using Pascal triangle, using a Pascal triangle. Yes, and we're saying that that has some form of limitation. It comes with its own form of limitation. What do I mean by that? Imagine that we're being told to expand something like x plus y to the power 100. The Pascal triangle will be limited. We cannot be able to do that using the Pascal triangle. So we're going to do what we call the binomial theorem proper. We're going to look at solving binomial using binomial theorem, using binomial theorem, solving binomial using a binomial theorem. All right, and even with that, there's another type that a question can be presented. So the third type is solving binomial theorem. So using binomial theorem, but of a different kind. Using binomial theorem, but it's of the different kind, of another kind. We'll take a look at that. Don't worry about that in a jiffy. We'll take a look at that. So the first one is using a Pascal triangle to solve a binomial. Second one is solving a binomial using the binomial theorem. The third one is solving a binomial theorem, but it's of a different kind. And then the fourth, let me see. The fourth one is, or let me probably write it here. Let me write the fourth one probably here. Okay. So the fourth one is, solving a binomial theorem. So solving binomial theorem, but we are going to use what? Approximations. So it's going to be based on approximations. We can be told to approximate stuff under the binomial theorem. Now the fifth one here is going to be solving binomial theorem, but using linear approximation. So still binomial theorem, but is based on linear approximation, linear approximation. Now the sixth one, right? The sixth one is what is known as binomial theorem, but applications. Binomial theorem, but we're going to look at how we can apply. What kind of applications can we see binomial theorem in there? So, right. So binomial theorem, but with applications. Binomial theorem, but with applications. Yes. Binomial theorem with applications. Yes. And then we go to part C. We go to part C. And in part C, we're going to be looking for finding a term. We're going to be doing finding a term in a binomial expansion. In a binomial expansion. So imagine that you've already expanded the binomial. They're asking you to what is the third term in the binomial expansion, or you could be asked to, just give us the fourth term without necessarily expanding everything. So this is the content of the video. This is going to be the content of the video. So we're saying that the definition, we're going to start with definition first, and then we're going to look at part B. We'll look at part B, and in part B, we're going to look at how we can solve binomial theorem. How we can solve binomial. How can we expand a binomial, and we can do that using the Pascal triangle. That's the first thing. And then the second thing is to remove the limitation of the Pascal triangle, which is actually solving a binomial using the binomial theorem. There's a theorem called the binomial theorem we're going to use that eliminates the Pascal triangle's restriction. Then the third thing is to still focus on binomial theorem, but it will take a different form. Then the fourth way of solving the binomial theorem is by approximation. And the fifth way is also by linear approximation. And the last way of solving a binomial is when we will have it being applied. We can see some form of applications where we can be able to perceive binomial theorem at play. And then the last thing we're going to be looking at, which is part C, we'll be looking for a term. We can be asked to look for a specific term within a binomial expansion. So if you're ready, to embark on this journey with me, buckle up and let's zoom straight right in. So we're going to look at the definition. We're going to look at the definition of a binomial. We are looking at the definition of a binomial. What is the definition of a binomial? Yes. First, we'll say that a binomial is an expression. It's an expression. That's the first thing we can say about a binomial. A binomial is saying it's an expression, and this expression it has the expression has two terms. It has two terms. And these two terms are connected. They are connected with either a plus or a minus sign. So the binomial is an expression, and it contains two terms, and these two terms are connected by a plus or a minus sign. So they are connected, to either a plus or minus sign. So it's an expression that has two terms connected to either a plus or a minus sign. All right. So we can look at an example. Let's take a look at an example. When we look at an example, we can say maybe 2p squared q, like that, minus maybe pq. So this is a binomial because it has two terms. This is the first term. You can see this is the first term here. And this is the second term. And it is connected by this sign here called the minus sign. It could also be connected by a positive sign. All right. It can be connected by a positive. It is often necessary to expand the power of a binomial, so sometimes we could also be asked to expand, a question can ask us to expand maybe x plus y to the power of 4. We could be asked to do something like this, and to be able to solve something like that, we need to apply a binomial expansion. All right, we need to do that in a binomial expansion. But to do this is going to be tedious. If we stick to we know x plus y to the power of 4 is actually x plus y, x plus y, another x plus y, and another x plus y. And I think that becomes tedious if we have to now multiply this by this, multiply the same thing by that, this by that, this by that. And when we finish, we're taking them one by. No, that's going to be tedious. It's going to be too much. It's going to be too much work, tedious. So that's where we need the tools in solving such situations, and that's called the binomial. All right, it's tedious. So we're going to take one of the ways. Now we're done with the definition that is an expression. Has two terms connected to either a plus or a minus sign. All right, and this example right there. And now we're going to look at a situation how we can be able to do an expansion using binomial. And the first method, all right. So methods, I'll say methods, which is the second part of the video, methods of solving a binomial. Methods of solving a binomial. Methods of solving a binomial. What are the methods? We said there are so many methods. There are 6 of them. Don't forget that. There are 6 of them. But we're going to look at the first method. Okay? We're going to look at the first method. And then the first method, it is known as the Pascal triangle. So we're saying that we can solve a binomial. We can solve a binomial, yes, using the Pascal triangle. We can be able to do that. So what is this name Pascal triangle? What is it all about? What's all this Pascal triangle about? It's about coefficients. So you can have the coefficients in a binomial form a certain parting. They form a certain parting, and that parting is useful for small values of n. So let's say that I'm going to create maybe 3 columns. So let's say there's a binomial. We have a binomial expansion here, a binomial here, and let's say we have coefficients here. All right, let's say we have coefficients here, and then we also have the expansion proper. Let's say we have the expansion here. So we are going to design. We want to arrive at what it means by what do we mean when we say the Pascal triangle. You're going to be able to witness that pretty much very soon. So we have the binomial, we have the coefficients, and we have the expansion. So let's start with, let's say, binomial, which is of the form, let's say, the binomial of the form, let's say, we have a plus x, or let's say x and y. Let me use x and y. Let's say we have x plus y to the power of 0. This is a binomial right here. What is going to be our coefficient? We know that any number raised to the power of 0 is 1. So our coefficient is going to be 1 for sure. It's going to be 1 for sure. And the expansion is also going to lead to 1. So that's not going to change. Then the next thing is to look at maybe x plus y to the power of 1. And the coefficient for that is we are going to have 2 different coefficients. 1 and 1 here, like that. We're going to have 1 and 1 like that. And then the expansion is going to be the first coefficient. The expansion is going to be this first coefficient. It's going to be 1. Is a coefficient. So 1 multiplied by the first variable, this variable, which is x. And because it's the power of 1, this is going to take the first highest degree, which is 1 here. And then the next variable is y, and then it's going to take on 0, like this, all multiplying. And then we're going to have plus the second coefficient, which is also 1, like this, multiplied by the x. The x is going to decrease from 1 to 0, and then the y will increase from 0 to 1. And then our expansion ends right there, because that means we're going to have 1 multiplied by x to the power 1 multiplied by 1, because any number raised to the power 0 is 1, plus 1 multiplied by 1, right? Multiplied by 1, because x to the power 0, is 1 multiplied by this y to the power 1. And that's going to give us x plus y. And that's our expansion for the second one. Now, the third one is to look at maybe x plus y to the power of 2. X plus y to the power of 2. X plus y to the power of 2. And you can see that this time around, the coefficients, we're going to start with the coefficient of 1 like this. But remember, we're going to add these two together. When we add them, we get 2, right? So we'll put a 2 in the middle of them. We're going to be in the middle of the 1 at the top. And then we'll put another 1 on the side of the 2 like this. Now, the expansion will begin. What it means is that we're going to have 1. We have the first coefficient is 1. So we're going to have 1 multiplied by the first variable, which is x. And it's going to take the highest degree, which is 2. So it's going to be 2 multiplied by y is going to take the least degree, which is 0, plus the second coefficient, which is 2, multiplied by the first variable. And the first variable is going to take, it's going to reduce in degree to 1, from 2 to 1, multiplied by y, which is also going to reduce, which is going to increase from 0, to 1, plus the last coefficient, which is 1, multiplied by x, reducing to 0, and then y goes to the highest, which is 2. And when you look at that, we're going to have x squared, because this is 1, multiplied, so we're going to get x squared plus 2xy plus y squared, because x to the power 0 is 1, like that. Then the next one we're going to have is maybe x plus 3, x plus y to the power 3, like this. And then the coefficient is still going to be 1 on the outside here. Then we're going to add these two. We're going to add them, and we're going to get 3. We're going to add these two again. We're going to get 3, and we're going to put a 1 outside of it like that. So we want to do for 4, we're going to have 1 here. We're going to add these two. We get 4 in the middle. We're going to add these two. We get 6 in the middle of the 3 and 3. We're going to add these two. We get 4 in the middle of 3 and 1. And we put 1 on the side like that. All right. But the coefficients are going to be the one to tell us what to do. So if you look at here, if we want to do this one, the first coefficient is going to be 1 multiplied by the first variable to the power of the highest degree, which is 4, right? Which is 4. Imagine that we're doing this is x plus y to the power 4. So to the power 4, to the power 4. And then the y will take the lowest, 0, plus the second coefficient is 4. Multiplied by x, the power, it will reduce to 3, and then the y goes to 1, it increase. Plus the next coefficient is 6. So it's going to be 6 multiplied by x squared. It reduces, and then the y goes to 2. Plus the next one is also 4. So we're going to have 4. X is going to reduce to 1, and then y goes to 3. Plus the last one, which is 1 multiplied by x 0, and then y to the power of 4, like that. Now, if you look carefully at the coefficient side, you can see right here, you can see clearly. Sorry, let me wipe this off. Take my time and do this. So you can see that this is following a certain pattern here. You can see that it's taking the shape of a triangle. If we keep going, it's taking a shape of a triangle, and that's what we call. That's why it's called the Pascal triangle. So the triangle is able to help us develop the coefficients. It's helping us to develop what's called the coefficient, these ones, so that we can be able to know what to do with the expansion. All right, these ones are the coefficients, like that, and we keep going. We keep going on and on. So this is how we solve a binomial using the Pascal triangle. All right, using the Pascal triangle. So we're going to solve some problems using the Pascal triangle, and let's see how that goes. So let's imagine for a second that we had been told to expand. Let's say expand. This is a question. We are going to expand 1 plus x, all right, 1 plus x to the power, no, let me do it this way. I'm going to change the question. So let's say we're going to expand 2a minus b to the power of 6. Okay, we're going to do this. So the first thing, if we go to, so using the Pascal triangle, we'll say that using the Pascal triangle, because we can be able to do this because the 6th degree here is not too much. So the best way is to use the Pascal triangle. So use the Pascal triangle. We can do the Pascal triangle on the side here where we have our 1 here. We're going to have our 1, 1. We do our 1 here. We add these, so we get 2. And put another 1 here. We have 1 here. We add this, we get 3. We add this, we get 3. And put a 1 here. We have 1 here. Add this, we get 4. Put it in the middle. Add this, we get 6. Put it in the middle. Add this and this, you get 4. Put it in the middle. And put 1 on the side here. So far, this is degree 0. This is 1, degree 2, degree 3, and degree 4. You can see double 4s in there. When you see double numbers in the coefficient in there, that's the term you're looking at. So because we are looking at to the power 4, we see 4 here, we see 5. Now to the power 5 is going to be 1 here. This and this will give us 5 in the middle. This will give us 10 in the middle. This will give us another 10 in the middle. This gives us 5 in the middle and a 1 right here. But we're looking for the 6th degree. Okay, so a 1 is going to be here. This and this is 6 in the middle. This is 15 in the middle. Then this is 20 in the middle. That is 15 in the middle. This is a 6 in the middle and 1 here. So you see, if we are told to solve maybe x plus y to the power 100, it's going to be difficult doing this over and over again. So the Pascal triangle will have a restriction. That's why we'll later on come to learn about the binomial theorem. So for this one, we are expanding 2a minus b to the power of 6. So it is easy to use this Pascal triangle. You can see it's in a triangle form. It's a triangle form. That's why it's called the Pascal triangle. So these are our coefficients. Our coefficients 1, 6, 15, 20, 15, 6, and 1. These are coefficients. So we'll say that we can let, x be equal to 2a. We can let x be equal to 2a. And then we can also let y, we can let y be equal to negative b. Our y is negative b right there. We're going to make our y to be negative b. And then we can start using the coefficients. From there. We're going to use the coefficients from there. All right. So we know that when we have 2a minus b to the power 6, okay, or let me do it right here so that everything will be uniform. I think I'm going to write all the way here. So bear with me. So we have 2a minus b to the power 6. And our first coefficient is 1. So we're going to show our 1 here. And it's going to multiply our x. Okay? It's going to multiply our x. But our x there is 2a. It's going to multiply our x to the power of the highest degree. What's the highest degree? Is 6. Like this. And it's also going to multiply our y, which will take the lowest degree, which is negative b is our y to the power 0, like this. Then the next thing is the next coefficient, which is 6, multiplying our x, which is 2a, to the power 5. Is going to reduce. And then our y rather goes up by 1, like that. Plus, the next thing is our second coefficient, which is 15, multiplied by our x, which is 2a. Our 2a goes down again to 4, multiplied by our y, which is negative b. Our y is negative b to the power of 2, because it has to go up 1, 2. So you can see that the x descends. The x is descending from 6, 5, 4, like that, in that order. And then the y is rather ascends. So let me write our coefficient somewhere. Let me write the coefficient somewhere. The coefficients are 1, 6, 15, 20, 15, 1, 6, 15, 20, 15, 6, and 1. That's our coefficient. So that I can wipe off this and then we can continue right there. Okay. Now the next one, what's our next coefficient? We're done with the 1, 6, 15. The next one is 20. Our next coefficient is 20. Our next coefficient is 20. So we have 20. Our next coefficient is 20. And then our x is 2a to the power of what? It descends to 3 multiplied by our y, which is negative b. Our negative b goes up to 3 plus the next coefficient is 15 15 multiplied by x, and our x there is 2a. Our x there is 2a. And then that also descends to 2. And then our y, which is negative b, our y, negative b, goes up to 4. It goes up to 4. And then we continue. Let me see, let me write it here. Maybe plus. The next coefficient is 6. Or I should come back a little bit. Let me come back a little bit, like maybe here. The next one is 6. The coefficient is going to be 6. We're done with this one. So the next one is coefficient of 6. Multiplied by our x, which is 2a, to the power of what? 1. It descends from 2 to 1. Multiplied by our negative b, which is our y, and that goes up by 5. Plus, the last coefficient is 1. So we have 1 multiplied by our x, 2a, goes to 0. And then the y, which is negative b, goes to the highest degree, which is 6. And then we begin to solve this particular problem. Can you see that? We begin to solve that. Now, here, we're going to have 1 dot 2a to the power of 6 multiplied by 1, because any number to the power of 0 is 1. And then we're going to still have, because of this is negative b to the power 1, the sign changes to minus 6 to the power 2a to the power 5b, like this. And then this is going to go to positive. It's going to be positive. So we're going to have plus 15 2a to the power 4b squared. This one, negative b cubed, is the same as saying negative b times negative b times negative b. This gives us positive b squared multiplied by negative b, and that gives us negative b cubed. So that means this is negative. So the sign should change to negative 20 into 2a to the power 3 b cubed, like that. Plus this negative b to the power of 4 is going to be b4, because we are multiplying it 4 times. So the first two negative numbers will be positive, and the other one is also positive. It's still positive. So plus 15, we're going to have plus 15, 2a to the power 2, and then we have b4 to the power of b4, like this. And then here, this is going to be negative. So we're going to have negative 6 2a. Well, this is to the power 1. Can you see that? To the power 1. So we're going to have negative 6 2a b5, like this. And this is also going to give a plus 1 times 1, because any number raised to the power 0 is 1. And then times b to the power 6. Now, let's see how we can simplify this. Now, this is going to give us 2 to the power 6, a to the power 6. But 1 and 1 is just 1, right? And it's going to give us minus 6 into 2 to the power 5, a to the power 5, b. And it's going to give us plus 15, 2 to the power 4, and a to the power 4. 2 to the power 4, and a to the power 4, and b squared. And this is going to give us minus this one here. It's going to give us minus 20 into 2 to the power 3, a to the power 3, b cubed. All right, and then this one will give us plus 15, 2 to the power 2, like this, a squared, and then we have b4. And this one is going to give us minus 6 into 2, 6 into 2a, b5. And then the last one is going to give us plus b6, like in that order. And then we're going to have equal to this 2 to the power 6. I think it's 2 to the power 5 is 32. Yeah, I believe. And then times 2 will give us 64. So it's going to give us 64a to the power 6. And then this is 32, like I said, multiplied by 6. You're going to get minus 2, carry 1, 18, 192, a to the power 5b. And then this is going to give us 16, I guess. Is it 16? I think so. 2 to the power 4 times 4 is 16. So we're going to have plus, so we're going to have 15, 15 times 16, basically. So we can say that 15 times 10 is 150. And then 15 times 6 is 2 of the 15 is 30 times 3, so 90. So 90 plus 150 is 240. So we're going to have 240 a4 b squared. Now this is going to give us 8. 8 times 20 is 160. We're going to give negative 160 a cube b cube. Then we're going to have this is 4. 4 times 15 is 60. So we're going to get 60 a squared b4. And then this is going to give us minus 2 times 6 is 12. So negative 12. We're going to get negative, sorry about that. We're going to have negative, sorry about this. We're going to have negative, we're going to have negative 12. We're going to have negative 12a, negative 12a. Yeah, this and this gives us negative 12a. And then we have our b to the power 5 coming, plus b to the power 6. In that order, in that order, in that order. And then that will be, if there's nothing else to add or do, that sends us to the final answer. That gives us the final answer, like that. All right. So this is how we use the Pascal triangle. You have to pick one. Pick up the coefficients. Sorry, pick up the coefficient first, and then the coefficient is the one that's going to guide us into knowing what to do and what not to do, what to do and what not to do, what to do and what not to do. So now we're going to go into what we call the binomial theorem itself. Okay, something that's able to address, something that can be able to address the shortfalls or the shortcomings of the Pascal triangle. All right, so let's take a look at a different situation. All right, we're looking at a different situation. So let's say you're being told to expand. You're being told to expand, let's say x plus y to the power 100 like this. We cannot use Pascal because it's going to be too tedious. We have to keep drawing a triangle all the way. Maybe we might need a long book to do that. And that's even tedious. We want to find the best way and the most efficient way of solving it. So remember that we said that we looked at first we looked at the definition. We looked at the definition of a binomial, right? We are done with that. We looked at that. We say it's an expression that has two terms. We are done with this. It has two terms and it's connected by a plus or a minus. Now we're looking at what? The methods. We're looking at methods of solving a binomial. That's what we are doing now. And we are done with the first one. The first one was Pascal triangle, right? The first one was a Pascal triangle. And we are done with that. We're done with that. So we're moving on to the second one. And we're saying that the second one helps address the restriction. The second one addresses the restriction of Pascal. And that second one is known as this second one is known as the binomial theorem. The binomial theorem. So that's what we're looking at the moment. That's where we are now. So we're going to be looking at what we call the binomial theorem. The binomial theorem, we're looking at the binomial theorem. That's what we're looking at. Okay? We say using a Pascal triangle, using a Pascal triangle to expand, let's say, x plus y to the power 100 will be tedious since the construction of the triangular array will be lengthy. Doing the triangle will be too lengthy. A more general method is known as the binomial theorem, and we'll use that in expanding powers that are very huge in doing that. So the binomial theorem is a formula. So it's a formula. So we'll say the binomial theorem. We can say it's a formula. The binomial theorem, it's a formula. It's a formula. Binomial theorem is a formula for raising a binomial expression. All right, for raising formula for raising a binomial for raising a binomial expression or raising a binomial expression to a higher to a higher to a higher power to a higher power to a higher power without without lengthy multiplication, or to a higher power without using Pascal. So that's the binomial theorem. It's a formula. And we're going to look at the general formula of that. Okay, so let's imagine we have x plus y to the power n. The general formula says a to the power, the x will take the nth term, all right, the nth degree plus n combination 1. We'll look at that. I know I'm introducing something strange, but don't worry about that. We'll take care of that. Now, plus n combination 1, and we're multiplying that by a, we are multiplying that, we're going to multiply that by x, yes, we're going to multiply by x to the power n minus 1, and then we're going to also multiply by y. We're going to multiply by y, like this. Then the next one is going to be n combination 2. N combination 2 multiplied by x to the power n minus 2 multiplied by y squared, like this. All right. And then the next one is going to be n combination 3, x to the power n minus 3, y to the degree 3, and then we're going to, it keeps going on and on and on because you're dealing with the nth term, on and on and on, and then it comes to having n, it will continue plus n combination r, because we don't know, it can keep going. Maybe the number could be 100 or 1,000, the r could be 1,000, and then the x will be n minus that r, because you can see here when here is 3 is minus that, when here is 2 is minus that. Can you see that? So if here is r, it's supposed to be n minus r, and then we're also going to multiply that by y to the power r. You can see that when 3 is here, 3 is also there. 2 is here, 2 is on the y. So it's going to be y to the power r all the way to y to the last degree, which is n, right there. So this is a general term. Now we're going to look at a notation. There's a notation, a strange notation. We were solving this in a very friendly way. All of a sudden, a strange notation. We need to take a look at that. The notation, what is this? That notation, NCR. Why are we saying it's NCR? Because if we keep doing this notation here, that notation tends to this right here. NCR is known as N combination R. We say it is known as N combination R. That's how it's read, or how you read it. N combination R. All right. And another way of writing this n combination r is the same as saying nr, like this. It's the same thing. Anytime you see nr like that, in like it's not a vector, but like in that shape or form, then we are still talking about what the notation n combination r is the same thing. So let's take a look at what we mean by that. So let me take a fresh page. Okay, so we're saying that ncr, we're saying that it's the same as nr, like this. And we're saying that they all mean the same thing. It's equal to saying what? N combination r. That's all we're saying. We're saying that they mean the same thing. So let's say that we have something like maybe 5 combination 2, for example. All right, we're saying that that's 5 combination 2 is the same as 5 and 2. We can write that as such, and we're saying that is 5 combination 2, right? Now, how do we express it? There's a formula. So first of all, the NCR is a formula. It is n. This is called factorial divided by n minus r factorial, and then you multiply it with r factorial. So we are saying that when you see something like this, when you see something like this somewhere, maybe this, it's called n factorial. N factorial. That's how you read it. N factorial. Now n factorial means something, right? When you say n factorial, it means something. So n factorial. Let's take a look at that. Sorry about that. When you say n factorial, it means something. All right. So let's say example 5 factorial. It means 5 times 4 times 3 times 2 and then times 1. That's what it means. 5 times yes, 5 times 4 times 3 times 2 times 1. That's what it means. So the top part here is n factorial. All right, it's n factorial. So we keep subtracting 1 from it. All right. So let's take an example. Let's say that we have 5 combination 3. So that means it's going to be 5 factorial. The n, this one is the n factorial. This one is the n. So this is the n, 5 factorial divided by n, which is the 5 minus the 3 factorial, and then the r, which is this 3 factorial. Okay, remember that. So okay, let me take my time and rewrite that for yes, it's the same thing. All right, so we're going to have 5 factorial divided by this, and this will give us 2 factorial multiplied by 3 factorial. Can you see that? Now we can solve that by saying that this 5 factorial, okay, let me rewrite it again. 2 factorial, 3 factorial. We're saying the same as 5. The top part is going to be 5 times 4 times 3 times 2 times 1. And then the 2 factorial is going to give us 2 times 1, right? And the 3 factorial is going to give us 3 times 2 times 1, like that. And you can clearly see that this will cancel out that. This will go into the 2, and then the answer becomes 10, like that. That's how we solve anything anything related to the factorial. All right, anything related to the factorial. Okay, so don't forget that in our general term, the general expression, don't forget this expression. We said that if you have x plus y to the power n, we said that the x will take on the highest degree. Don't forget that. And then we said that plus n, we said n combination 1. All right, n combination 1, and you have our x n minus 1y plus, we said that we're going to have n combination 2. We have our x n minus 2 y2 plus dot dot plus it continues and goes to n combination 3. That is going to continue that same pattern, and you're going to have x to the power n minus r yr plus dot dot, and then it ends at y to the power r. This is a general term. So if you want to break down this thing here, that's the coefficients we are looking for. These are the coefficients because you're not using the Pascal triangle. These are the coefficients by the side of it right here. So this is going to be something like n factorial, right? This is going to be our n, all right? We're going to put in the n. So this is going to be like n factorial divided by n minus 2 factorial, and then you're going to have 2 factorial, like that. And that gives you the coefficient for this side, and then you have your x n minus 2 y2 plus dot dot in that order. All right, n factorial divided by n minus r factorial, you have x n minus r y to the power r plus dot dot plus y to the power r, like that. So basically, when we are doing a binomial that is very huge in the degree, and we apply this general formula called the binomial theorem, we need to do the n combination 1 or n combination r to be able to determine the coefficients of the terms as we move along. So that's pretty much removing the restrictions, removing the restrictions of the Pascal triangle, removing the restrictions of the Pascal triangle. So let's take a look at a problem that we can do. Let's imagine that we're going to imagine that we've been given a question to solve. We've been given a question to solve. All right, given a problem to solve, and the question says, using a binomial theorem, write down and simplify. All right, we're going to write down and simplify the terms of the expansion of. So we have been basically asked to expand 2 plus x all to the power of 7 using the binomial theorem. Using the binomial theorem. So here we are being restricted to the binomial theorem. We don't have any other method. We are not being encouraged to use other methods. So we are restricted to using the binomial theorem formula. All right, and remember, we said that using the binomial theorem, all right, using the binomial theorem, we said that if you have x plus y to the power n, we're saying that is the same as x to the power n, right? Don't forget that x to the power n plus n, right? We said that plus n combination 1, and then you have your x n minus what? nx minus 1 y1 plus n combination 2 x n minus 2 y2 in that order. All right, in that order, so we get to n combination r x n minus r y r plus dot dot plus y to the power of n. All right, so since we're using that, we can say that our x, okay, we'll make our, in this particular question, we can make our x here. Our x is our 2, and then our y is our x in there. All right, so this is our 2, and this is our x, pretty much. So we're going to solve and say that 2 plus x to the power 7 is the first x to the power n. X to the power n, and our x here is 2. So we're going to have 2 to the power n. Our n is what? Our n is 7. This is the n. So 2 to the power 7 plus n, which is 7, combination 1. And then we have our x, which is 2 to the power, which is 2 to the power n, which is n minus 1, like this. And then to the power, and we are multiplying by y to the power of 1. What is y? Y is x. So x to the power 1, like this. Plus, the next one is going to be n, which is 7, combination 2. And then we're going to have x, which is 2 to the power 7 minus 2. Y, which is x to the power 2. In that order. And then we're going to have y, all right? I didn't even indicate y, right? So here it's going to be y1, So I said this is our x, which is, okay, this is our y. Sorry, this is our x, and this is our y. Okay, so that's good. We continue by having 7 combination 3 multiplied by our x to the power 7 minus 3, x to the power 3 plus 7 combination 4, 2 into 7 minus 4, x to the power 4 plus 7 combination 5 into 2 into 7 minus 5, x to the power of 5, x to the power of 5. And then we'll continue. 7 combination 6, 2 to the power 7 minus 6, and we also have x to the power of 6. Then the last term will be 7 combination 7, 2 to the power 7 minus 7, x to the power 7. So this is how we apply the binomial theorem. But we need to break down these things here. We need to break this one here. We know this is going to be 7 factorial. Remember the formula we said n combination r is n factorial divided by n minus r factorial multiplied by r factorial. So our n there is 7 factorial divided by n minus r, which is 1 factorial. And then the factorial there is going to be, the r there is going to be 1 factorial. And then we're going to have 2 to the power of 6. Can you see that? Multiplied by x. And it's 2 to the power of 7 here. Plus, we're going to have 7 factorial divided by 7 minus 2 factorial. And we're going to have 2 factorial, which is our r. We're going to have to multiply by 2 to the power of 5 x squared. Plus 7 factorial divided by 7 minus 3 factorial, 3 factorial. And I'm going to have 2 to the power of 4 x to the power of 3. Plus 7 factorial divided by 7 minus 4 factorial multiplied by 4 factorial. Yes, multiplied by 4 factorial. And then we have 2 multiplied by 2 to the power of 3 x4. And then we continue to have plus 7 plus 7 factorial divided by 7 minus 5 factorial, 5 factorial multiplied by 2 squared x5. All right, and then we're I'm gonna add it to this one. We're on this term here, this one right here. 7 factorial divided by 7 minus 6 factorial, 6 factorial multiplied by 2 to the power 1 x6 plus this term right here. And kindly wipe the sign, and we continue. We're going to have 7 factorial, we are here, divided by 7, which is n, minus r. The r here is 7 factorial, and then we're going to have r factorial, which is 7 factorial. And we're multiplying by 2 to the power 0. This one is 2 to the power 0. Go this 7 minus 7 is 0. Multiplied by the x to the power 7. I hope this is clarifying a lot of things. So now we're going to have, it's equal to this one here. It's 2 to the power 7 plus 7 factorial divided by 6 factorial multiplied by 2 to the power 6. 2 to the power 6. Okay, let me write it. I'm not going to change it. 2 to the power 6 x like this plus 7 factorial divided by 5 factorial 2 factorial 2 to the power 5, right? And you have x squared plus 7 factorial divided by 4 factorial 3 factorial. You have 2 to the power 4 multiplied by s cubed plus 7 factorial divided by 3 factorial 3 divided by 3 factorial multiplied by 4 factorial to the power, and multiplying me by 2 to the power 3 x4 plus, we are here in case you don't know where we are here, right here. We're going to have 7 factorial divided by 2 factorial, this is 2 factorial multiplied by 5 factorial, which is here, to the power 2 squared x to the power 5, right? And then we are left with these two terms. These two terms, we can put them right here, plus 7 factorial divided by 1 factorial, 6 factorial. This one is 1 factorial. And we have 2, this is going to be 2. 2 to the power 1 is 2, multiplied by x, which is multiplied by x to the power 6, plus 7 factorial, we are here, divided by 0 factorial, multiplied by 7 factorial. And then we are multiplying this also. I'm multiplying this also by x to the power 7 in that order. Now we're going to look at, let's take a look at here. We're going to have 2 to the power 7. We know 2 to the power, if you have 2 to the power 5, it's 32. So we multiply by another 2, that gives us 2 to the power 6, that's 64. Multiplied by another 2 is 2 to the power 7, which is 128. So we can say that here, we're going to get 128 for this one. Plus 2 to the power 6 is 64. So we're going to get 64, right? And 7 factorial and 6 factorial. 6 factorial will cancel. We're going to get, if you look at it, we're going to multiply it by 7x. This is x here, and then the 7 will come. Why? Because if you have 7 factorial divided by 6 factorial, the top is basically 7 times 6 times 5 times 4 times 3 times 2 times 1. divided by the denominator is 6 times 5 times 4 times 3 times 2 times 1. And this 6 going will cancel out this and we're left with 7. That's how come I'm having 7 only there. That's why we're having 7 only there. So we continue. Plus 2 to the power 5 is 32. So we're going to have 32 multiplied by 7 factorial. We have 7 factorial. The top part is going to be 7 times 6 times in that order. The down part is going to be the 5 factorial, which will cancel out the 5 factorial on top. So if you look at it, you're going to get 7 times 6 times 5 times 4 times 3 times 2 for the numerator, this one. Then the denominator is 5 factorial, which is 5 times 4 times 3 times 2 times 1, which will cancel out. And then the bottom is still 2 factorial, which is 2 times 1, right? So we're going to have this 2 cancel this 6 to be 3, and you get 21. So we're going to have 32 times 21 x squared, like that. Like that, in that order. And then we continue with 7 factorial and 4 factorial and 3 factorial. So the top part, this 4 factorial cancel the 4 factorial at the top, and we're going to have 7 times 6 times 5 on the top, and the denominator is going to be 3 times 2 times 1. This will go here to be 2. And then you're going to have this 2 also cancel out, and you're going to have 35. So we're going to have plus, this times this is 16. So 16 times the 35 that we worked out times x cubed, like that, in that order. In that order. In that order. Plus, we're going to have this is the same thing as what happens. So we're going to still have 2 cubed here. It's going to be 8, and then the whole of this is the 35 that we did previously. It's the same thing. And then we multiply by x to the power 4 plus, if you look at here and here, they're the same. So whatever we got for this side was 32 times 21. No, it was 21, right? So we're going to get 2 squared, which is 4 times 21 x to the power 5. And then here, we're going to have this 6 factorial, cancel the 6 factorial on top, and we're going to have 7 we're going to have 7 on top, which is going to be 7 times this 2, will be 14 x6, and then this whole thing goes to 1. 0 factorial is 1. All goes to 1, and then we have x to the power 7 in that order, like this. So final answer is just to simplify. You have 128 plus this times this, you work it out, add your x. This times this, you work it out, you have your x squared. Plus this times this, work it out, have your x cubed attached to it. Multiply this, and have your x4 attached to it. Multiply this, which is 80, I think 84, sorry. Plus 84 x5. And then this one will continue. This one and this one will add up to it. So I hope this is clear. This is solving expanding a problem using the binomial theorem formula. Solve the problem using the binomial theorem formula. Now we are going to be looking at another kind. We're going to look at another kind where you're having like a rational index, all right, or like a 1 plus. So let's take a look at that. So currently we are going to the third method. We're going to the third method. We're moving to the third method. But before we do that, if you haven't yet subscribed to our channel, we would like you to do so. Help us by subscribing and turning on your notification bell so that whenever anytime we do a video, you'll be notified. And that way we can also grow our channel together. Help us grow this channel like a family together, and it will put us in a position where we'll help as many people around the world as possible. In addition, if you haven't yet subscribed, if you're already a subscriber, then we'd like to thank you for subscribing. We want to say a big thank you for helping us grow the channel together. But let's continue. We currently we started off, binomial. We started off with a definition, if you remember. Started with a definition, and then we came to the methods. And then with the methods, we're saying that with the methods, we did the first one, Pascal triangle. We use the Pascal triangle to solve a binomial. But we said that the second one is Pascal will not help us because it could be tedious. So we came out with what we call we discussed what we call the binomial theorem. We discussed what we call the binomial theorem, which addresses the limitations that the Pascal triangle cannot be able to solve. That's what we did. And now we're currently going to the third type. It's still binomial. It's still binomial theorem. It's still binomial theorem. However, it's of another kind. However, it's of another kind, and that's what we're going to be taking a look at as we progress. So we're going to look at binomial theorem, solving binomial theorem, solving a binomial theorem problem, binomial theorem problem using another kind. Another kind. So the binomial theorem should be of a certain kind. It should be of a certain kind, and then everything. So we are saying that if n is any rational value, positive or negative, then the general binomial is. So let's say that. Imagine that you have a binomial of this form, maybe 1 plus x. 1 plus x to the power of n. We are saying that it's the same as 1 plus nx plus n minus 1 divided by 2 factorial, and it's going to be x squared, plus n minus 1 n minus 2 all over 3 factorial multiplied by x cubed plus dot dot. It continues like that. It continues like that. So now if we are being asked to specifically follow this kind, if we are being asked to follow this kind, and we are given something like a plus x to the power of n, then we need to make this one 1. And to do that, we need to factor. All right, we need to have it as a plus x, like this. Okay, we need to have it like that. Sorry, let me do it very well. So we need to have it as the inside first and then the main outside. So we need to factor out the inside by a. So the inside, we bring a out, we're going to have 1 here because we multiply the a by 1, you get back the a. So a comes out, you have a 1. But this time it's going to be plus x divided by a. So that when this multiplies the whole of that, that's a multiplied by x over a, it cancels out and you have our x, and we come back to here, where we started. We come back to where we started. So pretty much our a into 1 plus x over a into to the power n. To the power n. Sorry, not to the power n. That's the inside. What we have just written is just the inside. Is this one. What we've written here is the whole of that. Is the a plus the x. Can you see that? Because this multiplying this gives you this. And this multiplying this term here gives you x. Because we said a times x over a cancels out. I hope you can see that. So that's just what we have done so far. Let me do it again. Let me write it again. It's just the inside. So the inside is a into 1 plus x over a, like that. And then the whole outside is the n. Now remember, you remember when we have a, b to n, we said it's the same as a having the n, and then the b also taking it on, right? So if that's the case, we're going to have this a take on this n. And then we're also going to have this 1 plus x over a also take on the n, like that. And then we're able to wipe off this cleanly to go. Wipe off this cleanly to go. All right. So if we are being asked to use this format to do the binomial expansion, we first of all have to do it this way first, so that this one now looks like 1 plus x to the power of n, right? Because this x there, this x is the same as the x over a. The same thing. All right. It's in that same format. So it makes matters a bit less cumbersome. It makes it a bit less cumbersome. All right. Now let's take a look at maybe another situation where we are being given something like 2. They're telling us to expand maybe 2 minus x to the power of half. So the first thing is to change the inside. The inside is going to be 2 minus x is like this. This is the inside, and then the outside is this half right here. Now the inside, we'll factor 2 out in the inside, and we're going to get 1 minus x divided by 2. So that's the inside, right? And it's the power, all to the power of half. And then that gives us the 2 taking on the half, and then the 1 minus the x over 2 also taking on the half. in that order, also taking on the half in that order, so that we always arrive at here. We are able to get something like this to be able um, to continue. Yeah, to be able to continue. All right. So let's take a look at maybe some few. Let's take example of some few examples. Let's say that we have a question here. Let's say the question says that we should expand. Let's say expand 2x minus 1 to the power of 5, for example. All right. Sorry about that. All right. Uh, 2x minus 1 to the power of 5. Now, we could use a normal binomial theorem, but this time around it's of another kind. We can say that we can work on the inside first. Okay, we can work on our inside first by factoring out maybe the 2. All right, by factoring out the 2, okay, we can do it in so many ways. We can factor out the 2 and work it out with it, or we can just say that we should let our we can let our we can factor out 1, right? If we factor out 1, or we factor out negative, sorry, if we factor out negative, we're going to have something like this. If we factor out a negative, in the inside, it's going to be negative into, like this, negative 2x plus 1. And then the whole thing is to the power of 5. So that this negative multiplying this was negative multiplying negative 2x is the same as negative 1 multiplying negative 2x. And that gives us 2x. And this 2x is what is already here. Then this negative multiplying this one is going to be negative multiplying plus 1. It's the same as negative 1 multiplying plus 1. And that gives us negative 1, which is what is already here. So we can be able to manipulate that. Let me take it again. So that's where the manipulation comes in. 2x minus. So we have 2x minus 1 to the power of 5. And we are saying that we should factorize negative out on the inside. So you're going to have negative 2x plus 1. And then the outside will take it like that. And then we're going to have this negative taking on the 5 here. And then also you're going to have the negative 2x plus 1 also taking on the power 5 right there. So this is going to give us negative 1 to the power 5 into 1. Because this is positive, you can write 1 minus 2x to the power of 5. 1 minus 2x to the power of 1? 5. Okay? We can be able to do that. So we can be able to focus on just solving this. And then when we finish, we multiply everything by this guy here. We can also be able to do that. Now, if we have 1 minus 2x to the power of 5, we can say that we can let our x be the negative 2x, right? We can let our x will be equal to the negative 2x, like this. Okay, and our n will be equal to 5. Because remember that we said that this is we can solve a binomial in this form, 1 plus x to the power n. Don't forget that. And if we want to do that, we already have the 1, and then this is the x right there. All right. So we can be able to apply that to wherever we are going. Sorry about that. All right. So let's take the general formula. The general formula says 1 plus x to the power of n. All right. We said it's the same as 1 plus nx plus n minus 1 divided by 2 factorial x squared plus n minus 2, right? n minus 2, sorry, n minus 1, n minus 2, sorry about that. It's going to be n minus 1, n minus 2, 3 factorial s cubed plus n minus 1, n minus 2, n minus 3, 4 factorial x4 plus n minus 1, n minus 2, n minus 3, n minus 4, divided by 5 factorial, multiplied by x5. So if we are saying that our x is this, we're just going to plug it in. We're just going to do a plug in right here. It's going to be 1 plus the n is, our n is 5, multiplied by our x, and our x is negative 2x, plus our n is what? 5 into 4 divided by 2 factorial, multiplied by x squared, plus the n is 5, 4, 3 divided by 3 factorial, and multiply by x cubed, plus 5, 4, 3, 2 divided by 4 factorial of x4, plus 5, 4, 3, 2, 2, 1, right? 2, 1 divided by 5 factorial, multiplied by x to the power 5, in that order. Okay. All right. So we're going to have 1 minus 10x, for this and this, minus 10x. Now, this 2 factorial is just 2 times 2. There's 2 times 1, which will clear off one of the 2 for 2 times 2, which is 4. So it's going to be 10. It's going to be plus 10x squared. And then we continue. 3 factorial is 3 times 2 times 1, which is 6. And that's 6. This one will go here 1. It will go here 2. This 2 goes here 2. And we're going to get plus 10x cubed. Plus 10x cubed. Plus 4 factorial is going to be 4 times 3. The 3 will go out. And this 4 will cancel out. Times 2 times 1. So it's going to be 5x4. 5x4. Now, remember that we said the x there is our negative 2x. So we shouldn't forget that. Let's finish and plug that in back there. This 5 factorial is 5 times 4 times 3 times 2. And we're going to have plus x5. But remember, we said it's 1 minus 10x plus 10 into the x there is negative 2x squared plus the 10. This x going to negative 2x cubed plus 5 into negative 2x4 plus x5. Okay, so we can continue simplifying by having this one become 4x squared. This one becomes negative 8. This becomes negative 8 s cubed. This plus, and this becomes plus this to the power squared, cube, 4, and 5, right? So to the power 4, this is going to be 16 plus 5 times 16x4 plus x5. And then the rest will be to just simplify. The rest is just to be able to simplify that. Able to simplify something like that. Now, let's take a look at another question. All right. Let's look at another question. We can be told to expand. We can be told to expand maybe 1 minus 2x multiplying 1 plus x over 2 all to the power of 10. We can be asked to do something like this. And we already know that the first thing we can do is to solve this separately, right? We can solve this separately because of the form 1 plus x to the power n. And then we can also solve this one also separately, all right? And then we bring them, we bring them together. So if you look at something like this, it's going to be what? It's going to be 1 plus nx, right? Plus n minus 1, you add 2 factorial, x squared, plus n minus 2, okay? n minus 1, n minus 2, 3 factorial, and then you're going to have x cube and so on and so forth. And then we're just going to plug in. We are looking at only this one. We're going to have 1 plus the n there is 10. And there is 10. And then the x there is x over 2. All right, like that, plus the n there is 10, this is 9, 2 times 1, and then the x squared becomes the x there we said is x over 2 squared, and then we work out everything, and it leads us to whatever. So we need to add these terms. So let's imagine that when we do it, we're going to have this 1 minus 2x alone. Into parentheses, we're having our 1 plus 10 into x over 2 plus 10. Or let me simplify that. When you work it out, you're going to get 1 plus 10, sorry, 1 plus 5x plus 45 over 4 x squared plus dot 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 in that particular order. And then we can be able to expand, because this can multiply each of them like that, and then this can also multiply this and this, and then we arrange everything beautifully. I think the next thing I want us to look at is the fourth method, which deals with approximations. So we're going to look at binomial theorem involving approximations. So we're looking at binomial theorem using approximations. That's what we are going to look at. So we can be given a problem like this. We can be told to expand 1 minus 2x to the power 6, and then we can be told to find the value of 0. Find this value of 0.98 to the power 6. All right. So first of all, remember, we said that if there's a binomial expression of this kind, if there's a binomial of this kind, what's the kind of this kind? Where you have 1 plus x to the power n. All right. We said that when you have 1 plus x to the power n, we said the same as 1 plus nx plus n into n minus 1, right, divided by 2 factorial x squared plus n minus 1 n minus 2, 3 factorial, and then you're going to have what? X cubed, in that order. We said that. I don't know whether you do remember something like that. So we've been able to, we already have it in that form. So we can say that our 1 minus 2x to the power 6, all right, like this, is going to be 1 plus nx. Our n is 6. This 6. The x there is our negative 2x. Can you see that? This is our x. We have 1 plus x, like this n. So this x is the whole of that. All right. So it's going to be x, nx, all right, plus n, which is 6. And then 6 minus 1 is 5. Divided by 2 factorial is 2 times 1. And you're going to have here to be x squared. Plus, you have n, which is 6. You have n minus 1, which is 5. N minus 2, which is 4. Yes, divided by 3 factorial is 3 times 2 times 1. Multiplied by s cubed. Plus, you keep going and going and going on, to 4 terms. All right. Now, we keep going on, and then what we're going to have there, what it translates into, is that we end up having 1. This will give us minus 12x. When we simplify everything, this is going to be plus 60. It's going to give us plus 60. Minus 12x plus 60x squared. 60x squared. Because this x squared is supposed to be negative 2x all squared. So we're going to get this, and this is 4. And that 4 multiplied the 30, 120 divided by 2, 60. You're going to get your x squared. So simplify, take your time and simplify it. Then we're going to have minus 160, 160 x to the power of 3, and then it continues in that particular order. However, we are being told to use what? To simplify 0.98, right? 0.98 to the power of 6. Now, they all have the same exponent. But 0.98, how can we rewrite it in binomial form? We can write this as 1 minus 0.02. Can you see that? Because 1.00 and then 0.02. When you subtract, borrow 1 here, bring it here is 10, borrow another 1, it becomes 10 here, but it becomes 9. 2 minus the 10 is 8. Now you have 0 minus the 9 is 9, and then here's 0. So 0 is 0 is 0. About 0.98. So 0.98 to the power 6. It can be rewritten as 1 minus 0.02 all to the power of 6. Now, all we know is that this part is where we're going to plug in our x. When we see x, we put in this one there, negative 0.02. All right, I'm going to put negative, we're going to put 0.02. So we're going to have, God, this is what we have for 1 minus 2x to the power 6. So we're going to plug it in. We're going to have 1 minus the 12, and our x there for this simplification is 0.02 plus 60 into 0.02 to the power 2 minus 160 into 0.02 cube plus we keep going, plus we keep going, we keep going, we keep going. So that's how you solve binomial theorem using approximations. Using approximations. So you can be told to there can be another one that says expand, let's say 1 minus x to the power 7, and you can be told to find the value of 1.998 to the power 7. Find the value, all right, of 1.9987. And we know that we can manipulate this one and say it's 2 minus something. We can say it's 2 minus 0.002, right? 2 minus 0.00, I think 0.002. 0.002, and that will give us 1.998, and then that gives us to the power of the 7. But we can manipulate, we can still further manipulate this. The inside, we can bring 2 out, I think. We can bring 2 out, and then you have 1 here minus the 0.001, like this. And then everything is to the power 7. That way, the 2 can take on the 7. And then we also have 1 minus 0.001 also taking on the 7, like this. All right. So we can see that this 1 minus x to the power 7 is going to be the same as the 1 minus the 0.001 to the power 7. So we can see that this side and this side, they are the same. And then we use the coefficient and the term that we have found to be able to solve the problem. Okay. You will solve the problem. So we know that we have to work this based on the expansion we get for this. We'll get some expansion here. 1 plus nx plus n minus 1 n 2 factorial x squared, like that. Whatever values we're going to get is going to be what is here. It's going to be whatever we get there. And then we multiply everything by 2 to the power 2 to the power 7. So that's binomial theorem with approximations. Binomial theorem with approximations. Binomial theorem with approximations. Binomial theorem with approximations. Now let's quickly look at linear approximations. Let's look at linear approximations. Linear approximations. We've looked at approximations, but let's see how linear approximations apply here. Okay, how linear approximations apply here. So we're going to look at binomial theorem. Binomial theorem. And we're looking at linear approximations. Linear approximations. We'll look at linear approximations. Okay, linear approximation. So the binomial expansion. So let's look at that. There's a binomial expansion. We can be told to look for the linear approximation for. So let's take a question. We'll find the linear approximation. Linear approximation. We can be told to look for the linear approximation for maybe 1.005 to the power of 10. All right. They can also ask you square root of maybe 1.004, like that, in that order. So what we can do is that to manipulate this one. All right, we can expand it and say it's 1 plus the 0. We can split it. So it's 1 plus 0.05, like this. Because this 0.005, if you add it to 1, you're going to get what is right here. So we split it, and we have our 10 at the top here. All right, we have our 10 at the top there. All right, but we can say that if the x is sufficiently small, right? Got this x here. This 0.005 is too small. Too small. So if you have, let's say 1 plus x to the power n, but this x here is too small, all right, then we can approximate it to be 1 plus nx. We can approximate it to be 1 plus nx. So when, let's say you have 1.000102 to the power of 10, and then we want the binomial approximation for that, we can say this is the same as 1 plus 0.000102 to the power of 10. Yeah, we can say this. But you can see that this one is too small. And because it's too small, we can approximate it to be 1 plus the nx, where n is 10 and the x is what is the 0.000102, and then 1 plus, like in that order. And given that, we can see that this is our x and this is our n. So if we approximate this to be 1 plus nx, then we're going to get 1 plus our n there is 10. And then our x there is 0.005. And we're going to have 1 plus 10 into 5 over 1,000. 5 over 1,000. All right, because we have 0.005. And we want to move the zero. It's going to be 1, 2, 3. 3 zeros. So it's going to be divided by 1, 2, 3. Write 1 first and 3 zeros. The zero is now here, so you have the top to be 5. All right, and that's what we just did. And when we do that, 1 plus 10 to 5 divided by 1,000, this cancels out. 5 cancels out, and we get 20. So we get 1 plus 1 over 20 in that order. So what if we are told to approximate square root of 1.004, right? We're saying the same as 1.004 to the power of half, okay? But we say that 0.004 is too small, okay? So if it's too small, what do? We approximate it to be 1 plus nx, and that's going to be 1 plus the n is our half. Yes, 1 plus the n. The n is our half. And then the x there, is a 0.004, like that. So we have our n. This is n, and then this is our x. So we're going to get 1 plus 1 over 2 into 1, 2, 3. So we have 4 divided by 3, like that. And we are going to have 1 plus, this cancel becomes 2. We have 2 over 1,000, like that. And then we use fraction to solve the usual way. And we are able to arrive at linear approximations. So I hope things are getting a bit clearer. If you haven't yet subscribed to our channel, please help us so we can grow the channel together with you as a family, so we can help as many people around the world. We want to make tutoring very, very easy and to eliminate any form of tutoring cost, bring tutoring costs down. If you're currently a subscriber, we want to say a big thank you for supporting our channel. But today's video, we are looking at binomial theorem, and we started off looking at the binomial definition. We looked at the definition of a binomial, and then we look at the methods. We look at the methods, and the methods. We look at 5 ways already. We look at the Pascal, which was the first one. We look at the theorem, the binomial theorem, which is the second one. After the binomial theorem, we looked at the theorem that is of the form 1 plus x to the power n. And then the fourth one was to deal with the theorem, but with what? Approximations. Okay. And the next one, instead of the theorem with approximations, we're looking at the theorem with a linear approximation. Okay. Linear approximation. We've looked at that. And now we're going to be looking at the binomial applications. We're going to look at binomial applications. So let's take a look at binomial applications. Okay, which is our sixth method, because we've already done the linear approximation. So the sixth method. Imagine we have this question. The question says, if the radius, let's say you have if the radius of a sphere is increased, the radius of a sphere is increased by 2%. The radius is increased by 2%. What is the approximate percentage increase? What is? It says what is the approximate percentage? What's the approximate percentage increase in its volume? So basically, the radius goes up. You want to find out how does it impact the volume? Does the volume go up, and if it goes up, by how much? If it goes up, by how much? How much does it go up by? So we know we can start off nicely in a very, very peaceful way. If you can remember, I want you to cast your mind a little bit back, that the volume of a sphere is given by 4/3, 4/3 pi r cubed. Okay, and then we said that the r in there is the radius. The radius is the radius, the original. Nothing had happened. They didn't increase. Nothing happened. Now the new value, the new radius was increased. So if it was increased, so that's going to be new radius. We'll say that new radius is the 1 plus 2%, right? So it's going to be 100%. The new radius is going to be 100%. New radius is going to be 100%. You are adding it to the increase, to the 2%. So they're going to get 102%, which is the same as 102 divided by 100. And that's going to give us 1.02, because this zero should come up 1, 2, like that. So this is going to be 1.02 r. It's going to be 1. So the new radius is going to be 1.02 r, like that. That's a new radius. That's our new radius, right? But remember, we can split this 1.02 r, this 1.02 r. We can make it what? We can make it 1 plus 0.02 r, like this. We can write it like that, so that the new volume, we know that our original volume, we know the original volume is 4 over 3 pi r cubed, and then r is the radius, the original radius. Now, if we what would you think will be our new volume? What will be our new volume if what will be our new volume if our new r is actually 1.02 r? What becomes of the new volume? So the new volume will be, to rewrite the formula, it's going to be 4 over 3 into pi, and then the r there is our 1 plus 0.02 r, right? Our r there is 1 plus 0.02 r, and it's all to the power of 3. So that you and I are going to have 4 over 3 pi, and then this 3 will take on that. The 3 is going to be 1 plus 0.023, and then the r also takes on that. Beautifully, it takes on that. Now, that means we can be able to solve this. Can you see that? We can be able to solve this using a binomial, right? We can be able to solve that. We can be able to solve that using a binomial. But you see, we said that because it's 0.02, it's too small. It's too small. So we can say that this is the same as 1 plus nx. All right, so let me rewrite here. It's going to be 4 over 3 pi, 1 plus 0.02 to the power 3 r cubed. And we're saying it's too small. If it's too small, this becomes 1 plus nx. Don't forget, like this, r cubed. Now, n there is going to be 1 plus, the n there is 3. So it's going to be 3 times the x, and the x is 0.002, like this, and then it's r cubed, like that. It's 1 plus 3 multiplied by 0.02 r cubed, and then this one also goes to that, and we have our 4 over 3 pi. All right, so this is going to be 1.0, I think 1.06. 1.06 will be the inside here, and then you have your r cubed, and it's going to be 4 over 3 pi, in that order. And if we know what the radius is, we're just going to plug it right in there. We're going to plug it right in. So our volume went up by 6%. You can see that our volume went up by 6%. Our volume went up by 6%. Now let's take a look at another quick one. The question says that the radius, it says the radius of a cylinder, is reduced by 4%, and height increased by 2%. Determine the approximate percentage change in volume. So you're saying that change in volume. What's the change in volume? We don't know. So we have to always start with what we are looking for. We're looking for the volume, right? So we can say that what's the volume of a cylinder? That's I think what we need to know. So the volume of a cylinder is V equals pi r squared h. Yes, pi r squared h, where r is our, so r here is original radius, and then the h there is original height. All right. So it's saying that, let me rewrite here. So our new radius was what? Reduced by 4%. So that's basically 1 minus 100% minus 4%, which is 96%. And 96% is 96 over 100, which is 0.96. Well, these two zeros, so it's 1, 2. There's a dot here. So 0.96 will be the new radius. 0.96 0.96r is the new radius. Now, the new height was increased by 2%. So that's going to be 100% plus 2%, which is 102%, which is the same as 102 divided by 100. There's 2 zeros, so we'll move it here. 1, 2. So it's going to be 1.02, like that. So new height is equal to 1.02h. So we have new height, and then we also have new radius, like that. And I think that'll be a nice way to, plug it right in there. I think plug it in right in there, and then we're going to be good to go. All right. So our v here is pi. It doesn't change, but the radius changes. The radius becomes 0.96. Can you see that? Squared, and our h becomes 1.02 h, like this. Now, this one here, we can express it, we can change it and say it's the same as 1 minus 0.04. Can you see that? Yeah. And then we square it like this. All right. And then we have our 1.02. Sorry. So this is 0. So let me take my time. Sorry about that. Let me rewrite this. Please. Let me write this. Let me rewrite that. Okay. So our radius, what's our radius? We're saying our V, our volume, is going to be pi. Pi will not change, but our radius is this. This is our radius. It's 0.96 r before the squared comes in. And then our h is 1.02 h, like that. So that the inside, we can manipulate the inside. And then manipulating the inside, we're going to get 1 minus 0.0, can you see that? 0.04, like this, which gives us 0.96, and then there's an r. But then there's a square that affects everything. And then there's a 1 point. The 1.02, we can also be able to manipulate that. And that's going to be 1 plus 0.02, like that, with an h outside. And there's a pi, and there's our v. Now, the v still has a pi, but this squared affects this one here. So it's going to be 1 minus 0.04 squared, and you have our r squared, and you're going to have 1 plus 0.02 with an h here. If I move it here, v is going to be pi. It's going to be this one. But remember, this is too small. So it goes to 1 plus nx, like this. And then there's a square there. Oh, sorry. This is too small. So this whole expression becomes 1 plus nx. Remember, that's a linear approximation. If this number is too small, we use the linear approximation. Then we have 1 plus x to the power n, and this x is too small. It becomes 1 plus this nx. It's a linear approximation. So we just use that. This is our n. Sorry, this is our x, and this is our n. So that's what I just did. That's what I just did right there. 1 plus nx. We'll do our 1 plus nx right there. Okay. So 1 plus nx will be 0. What? So we're going to have, take the y here. We're going to have our pi. This is going to be 1 plus the n is the n there is a 2. And then the x there, our x there. Can you see our x? Our x is negative 0.04. Like that. 0.04. And then we close it with our r squared. Can you see this r squared will come there? This r squared. And then there's our 1 plus 0.02h. Now, this is also too small. So it's still also going to be into 1 plus nx. This is also going to be 1 plus nx. So it's going to be 1 plus n. Our n is 1. And then the x is that. So it's going to be 0.02, like that, with an h. With an h, like that. So we're going to have pi into, this is going to give me 1 minus 0.08 r squared. And it will give me 1 plus 0.02 h, like that. Like in that order. Like in that order. All right. Like in that order. Pretty much. Like in that order. Now they're all multiplying. So it's going to be pi r squared h. This r squared, they will come together. You're going to have 1 minus 0.08. And then you're going to get your 1 plus 0.02, like that. 1 plus, I'm going to get 1 plus 0.02 beautifully done, like that. And then we can see that this is what impacted the what? This is what is impacting. Let me take a different color. This whole thing here is what is changing the volume, because this is the original volume. This is the volume of the cylinder, and this is what is changing the volume. Please, if you don't understand, please pause the video, go back a little bit, or maybe you need to take a little break, come back, feel refreshed, and then keep going at it again. I think that the last thing we're going to be doing is when we are told to find the third part of this video is to find the term. We're looking at finding the term in a binomial, expansion. So you've expanded it, but they are specifically asking for a term. They are specifically asking for a specific term in there, a specific term right there. All right. So if there's like a general formula, if they want a specific term, it's a formula. It goes by this. It says n combination r, you multiply it by a. Oh, sorry. I like using x and y. So it's going to be x to the power n minus r multiplied by y to the power r, like that. Okay, multiplied by y to the power r, like this. So if a question is asked and it says write down and simplify the fifth term, let's say the question says find the fifth term in the binomial expansion, okay? Find the fifth term in the binomial expansion. And that binomial expansion, let's say, is 3 plus x to the power 7. Find the fifth term in the binomial expansion of this. So we don't need to expand everything. We're just going to use we're going to plug in the the formula, and then we see what we're going to get. So let's say that we know that this could be our x. This is our x here. Can you see that? This is our x, and then this is our y. And then this is our n. Can you see that? This is our n. So if they say the fifth term, okay, we are looking at NCR. We said the formula says NCR multiplied by x to the power n minus 3, y to the power 3. All right. So if we're looking for the fifth term, all right, the fifth term is going to be n combination 4, because the r there is 5. It's 5. The r there is going to be 5 minus 1. Okay, the r there is going to be 5 minus 1. Okay, the r, so our r is going to be 5 minus 1. Okay, so the formula, the n here, is going to be the 7. Then the c combination, the combination r, the r there is going to be 4, because we're looking for the fifth term. Multiplied by x to the power n, the n there is 7, right? The n there, if you look at it, the n there is going to be 7, and then minus the r. Our r there is 4. And then we multiply it by y, and then our y is what? Our y there is x. Can you see that? Our y there is x. So let me take it again. So that's the formula, right? We need to just plug in the values. Our n, we said, is 7. Can you see that? So we put 7 there. Combination r. The r there is 4. This one here. So put 4 here. Multiply by our x. What is our x? Our x is 3. So we put 3 to the power n, 7 minus the r, which is 4. Multiply by y. Our y there is x. And then our r is 4. So basically, we're going to get 7 combination 4 multiplied by 3 to the power 3 multiplied by x to the power 4. So if I bring this here, I'm getting 7 combination 4. The 3 by 3, 3 to the power 3 is 3 times 3 times 3. This is going to be 9 times 3, which is 27. So that's going to be times 27 x to the power 4. But what do we do to this? We know it's the same as 7 factorial. If I remember the formula, we said if you remember the formula, we said if you have n combination r, it is the n factorial divided by n minus the r. You subtract this from that factorial and then take r factorial. So here our n factorial is a 7. This is our n, 7 factorial. And our r is this 4 here. So it's going to be the n, the denominator says n minus r. What's our n? 7 minus r. What is our r? 4 factorial. And then we multiply by another r factorial. What's our r? 4 factorial, like this. Okay, and then we know that that's 7 factorial divided by 3, because 7 minus 4 is 3 factorial, 4 factorial. Can you see that? Now we're going to simplify by saying that that's 7 factorial divided by 3 factorial, 4 factorial. The numerator is going to be 7 times 6 times 5 times 4, 3 times 2 times 1, divided by 3 times 2 times 1, multiplied by this one, 4 factorial, 4 times 3 times 2 times 1. Now this 4 times 3 will all cancel the top here. This 3 times 2 will cancel this 6, and you're left with the top, which becomes 7 times 5, which is 35. So we can say that the fifth term is 35. Remember we said it was 7 combination 4 times 27 times x to the power 4 from here. Do you remember that? So this alone is giving us a 35. Multiplied by the 27, multiplied by x to the power 4. And that will be the fifth. That's going to give us our fifth term. So if a question specifically asks, hey, can you find the specific term within a binomial expansion? We shouldn't forget, this is the formula right here, this one. Once you know this formula, you're just going to plug in the values. You're just going to plug in the values and you're good to go. You're good to go. All right, you plug in the values and then you are good to go. But before we go, I was thinking to do maybe one more question, and then we go. But I think I'll end here, and then we'll come be watching out for our shorts videos. For the purpose of our short videos is to solve problems on each of the topics that we have treated. So there'll be more questions, more practice questions that will be coming on our short video concerning binomial theorem. So watch out for them, all right? Watch out for them. But I hope you had a great time with us, and thank you. If you haven't yet subscribed, please do us a favor by subscribing to our channel so that we can grow the channel together as a family and to help as many people around the world. If you're already a subscriber, thank you for supporting us. I'll come to you another time with another topic. Take care and bye.